Okay, this video contains the solutions for the calculator portion of the 1998 AB test. You're not going to use your calculator on every one of these, you'll find. There's probably about half of them. So 76, for example, does not need a calculator. And notice that they say that the exact answer doesn't necessarily appear. They'll usually give answers rounded to 3 decimal places. And that's what we'll do on the free response too. Okay, graph of a function f is shown above. Which of the following statements is false? F is continuous at A. Well, that's not true. That's a whole, right? So I think this is false. Let's just check the other ones. Does f have a relative maximum? Yeah, that is higher than all its neighbors, so that's true. That's true. Is A in the domain? Yeah, A, that just means there is a function value, and there is. That's true. Are the two one-sided limits? Yeah, as you come in on either side, they're coming to the same thing, so that's true. And that means D actually implies that this is true, right? The limit does exist. It's just that it's not continuous. It's got that missing spot there, so A is the correct answer. Number 77, looks like we'll need our calculator for that. Let f be the function given by f of x equals 3e to the 2x, and let g be the function, this 6x cubed. At what value of x do the graphs of f and g have parallel tangent lines? That's like asking when are their derivatives equal to each other. Well, the derivative of f of x is equal to 3e to the 2x times the derivative of what's inside. And the derivative of the g function is 18x squared. So we want to find out when are those two derivatives equal to each other. So 6e to the 2x, when is that equal to 18x squared? How do you solve something like that with your calculator? You get everything on one side, and you set it equal to 0. Look for the zeros. Or you could graph this and find the intersection if you prefer that method. So let's see if we can find that. You might have noticed that in the calculator part there are less problems, and that's because it does take a little bit longer to do this calculator entry stuff. So there's that. I'll go ahead and graph that. I don't know what window I have here, but it looks like it might be okay. Nope, maybe not. So, because all the answers are negative, aren't they? Looking at these answers, it looks like I probably just want to look from like -1 to 0. You could do the standard window if you want, but it doesn't matter. Here's the standard window. And there it is, crosses in between -1 and 0. So I'll go second calculate, find the 0 of that, and it's in between -1 and 0. And my calculator tells me it's -0.391, which is answer choice C. Okay, let's see. Radius of a circle is decreasing at a constant rate. That means it's going to be negative, of 0.1. So the radius, that's like dr dt. The radius is decreasing at a constant rate of -0.1. That's what that's telling me. In terms of the circumference C, what is the rate of change of the area of the circle in square centimeters per second? This is a related rates problem. So area is pi r squared. So taking the derivative of that, I get dA dt is equal to 2 pi r times dr dt. And they said in terms of the circumference C. So what we have to notice here is that is the circumference C. So dA dt is equal to the circumference times dr dt, which is -0.1. And that's answer choice B. Number 79. The graphs of the derivatives of 3 functions are shown above. Which of the functions has a relative maximum from A to B? Since these are the derivatives, a relative maximum is a spot where the derivative goes from increasing to decreasing, right? That would be a derivative that went from being positive to negative. So we're looking for places where we cross like this, going down, where we go from positive to negative. Let's see. This has one here, right? Goes from positive to negative. This doesn't. That would be a minimum, right? But it doesn't have any maximums. To have a maximum, it's got to cross from positive derivatives going up to negative derivatives going down. And this one's always increasing, so that doesn't have any maximums or minimums. So it's just f. And we have seen that one before. Number 80, the first derivative of the function is given here. How many critical values does f have on the open interval from 0 to 10? Critical values are places where the derivative is equal to 0 or undefined. And this is not going to, oh, it might be undefined. Where? Oh, but it's open interval, so the 0 there isn't going to be a problem. So let's take a look and graph it. So I have, let's see, the cosine of x. Notice how you have to enter. If you want to do cosine squared, you've got to put that in parentheses like that. Divided by x minus 1/5. And we'll graph and see how many zeros that has. Well, I think I need to look a little closer to that. Let's set my window a little bit better than that. I only care about from 0 to 10. And I want to look closer to the y-axis. So let's look from like -1 to 1 and see if we can see. There's 1, 2, 3, nope, nope. That was close. It looks like 1, 2, 3 places where the derivative is equal to 0. 3. They gave us the derivative, so we didn't have to do any calculus there. We just had to know that, oh, we're looking for zeros of that. Number 81. Let f be the function given by this, so that's the absolute value function, right? It's got a sharp point here. Which of the following statements about f are true? Is f continuous here? Sure. No jump, vertical asymptote, or hole, so that's true. Is f differentiable here? No, it's a sharp corner, so that's not true. Does f have an absolute minimum? Yes, that it never gets lower than this, so it looks like 1 and 3 are true. Number 82, if f is a continuous function and if the derivative of capital F is small f, which means f is an antiderivative of f of x, right? That's another way of saying that. Then this would be equal to, okay, let's see. Would have to do a u substitution here to find the antiderivative of this, right? If we let u equal 2x, then du would be equal to 2 dx. So I need a 2 in here and a 1/2 on the outside. So that means we got 1/2. Now those numbers are going to change from 2 to 6 of f of u du. And the antiderivative of this is the capital F function. So that's 1/2 this capital F function from 2 to 6. That's 1/2 of f of capital F of 6 minus capital F of 2. Now that looks like E. Okay. Looks like still we've only used our calculator, what, twice? Once? Twice? So let's see here. If a is not equal to 0, then this limit is, well, let's see, this looks like a factoring kind of limit. That's difference of 2 squares. That's also the difference of 2 squares. It's x squared plus a squared times x squared minus a squared. I guess I should have left that unfactored, right? Because this is x squared minus a squared. That's the same as that. So now I can plug in the a. Only one left on the top. If I plug a in here, that's a squared plus a squared. That's 2a squared. That's b. You could also use L'Hopital's rule on this. that would be another option. You can try that, see if that works for you. Number 84, we do not know how to do yet. I think I asked you to skip that one. Actually, let me go back and see if that's one that we could figure out anyway. I can't remember if I asked you to do that or not. Okay, so the population doubles. No, we can't do that. Just kidding. 85. The function f is continuous on the closed interval from 2 to 8 in values given here. Using these, what's the trapezoidal approximation of the area? Well, let's see. Trapezoids, we have the base, which would be 3 for that one, times the average of those. The average of 10 and 30 is 20. Plus, there's different ways to set up this formula, but this is the area of that trapezoid, right? Area of a trapezoid is the base times the average of the heights, or the height times the average of the bases, however you decide to call those. So that's what I'm doing here. This one has a base of 2 times the average of 30 and 40, which is 35. This has a base of 1 times the average of 40 and 20 is 30. So adding those up, we get 60 plus 70 plus 30, which is 160. I think maybe we saw that one before. That looks familiar. Don't know how to do 86. Number 87. Well, I know how to do it, and you will soon, but not yet. Which of the following is an equation of the tangent line for the graph of this at the point where f prime of x equals 1? Okay, so let's see. Let's find the derivative of that. 4x cubed plus 4x. And we want to know where this is equal to 1. So I think let's set the derivative plus 4x equal to 1, and then find the solution to that in our calculator, because we don't know what x value yet. So let's see, 4x cubed plus 4x. I'll subtract the 1 to the other side and see if I can figure out, oh, looks like it's right there. So second, calculate 0 of that. Looks like it's between 0 and 1. So that happens at x is equal to 0.237. Okay? So I want to find the tangent line when x is equal to this. So when x is equal to 0.237, I need a point and a slope. Well, this is the slope, right? So right off that can't possibly be right. These all have a slope of 1. I need the y-intercept. So let's see. When x is equal to 0.237, I need to find the y-coordinate. 0.237, comma, I'm going to plug that in here to find the y-coordinate. So let's see. I got 0.237 to the 4th plus 2 times 0.237 squared. That's 0.115. 0.115. And if you want to do it in point slope form, that would be y minus y is equal to m, which is 1, that's our slope, times x minus x. And then these are all in standard form, so I'm going to add that to the other side. So it looks like the y-intercept is going to be negative 0.237 plus 0.115, which is negative 0.122, which is D. Number 88, let f of x be an antiderivative of this. If f of 1 is equal to 0, then f of 9 is equal to, okay, well, we're talking about antiderivatives, so let's set up an integral here. You know what the integral of the natural log of x cubed over x. And where are we going to go from where to where? Well, since we're interested in 1 and 9, I'm going to go from 1 to 9. Right? Then that would be, if this is an antiderivative of that, this would be equal to f of 9 minus f of 1. Right? This is a fundamental theorem of calculus. If the capital F function is an antiderivative, then this is how we find antiderivatives. Right? And if this is equal to 0, that means f of 9, which we're looking for, is just equal to this. Now there's a couple ways you can do that. You could graph it. You should not be doing this. This is a calculator problem, so you should be going straight to your calculator here. You could say, okay, let me just graph that and go, let's see, that's the natural log of x cubed over x, and go ahead and graph that. And then you can go second calculate. Number 7 will find you the area from 1 to 9. That's about 5.827. It's right there. And the other possibility, if you don't feel like graphing it, you can just do math 9 as fn int, and then you can enter your function. You can do natural log of x cubed over x, right, comma x, always have to have the comma x there, comma 1, comma 9, and that'll do the exact same thing. It's up to you how you want to do that. Same answer. Okay? If g is a differentiable function such that it's always below the x-axis, so it's always negative, g is below 0, and this f prime of x is equal to this, which would be x minus 2, x plus 2 times g of x. And if we're talking about minimums and maximums, we could set up a number line. There's -2 and 2, and this is always negative, right? So testing numbers here, you should find that down here it's negative, in here it's positive, and up here it's negative, taking into account that this is always giving you a negative sign. Then, let's see, f has a relative maximum, let's see, it's decreasing and then increasing. So this would be a minimum, and this is a max here. Right, increasing, decreasing. So does a relative maximum, no, that's not right. There's a relative minimum at -2 and a relative maximum at 2. I think that looks good. Does a relative minimums at both? No. Relative maximums at both? No. It cannot be determined, short can. We just determined it. That's B. So what is this telling us? This is telling us that that piece of it is always negative. And I think we saw that one before too. Number 90, if the base of a triangle is increasing at a rate of 3 inches per minute, while its height is decreasing at a rate of 3 inches per minute, which of the following must be true about the area A of the triangle? Well, area is equal to 1/2 base times height. So if we're talking about rates of things increasing and decreasing, this is a related rates problem. So that's 1/2 times, I have to do the product rule on this, the derivative of the first, dB dt, times the second, plus the first times the derivative of the second. And let's see, the base is increasing, so this is 3, and the height is decreasing, so this is -3. Now let me rewrite that, give myself a little bit more room here. This is the rest of the work for number 90. Let me simplify that. So dA dt is equal to 1/2 times 3h minus 3b. Okay? So is the area always increasing? No, this could be negative. It looks like if, since those are both, you could factor the 3 out if you wanted to. That's the same as 3/2 h minus b. So this is going to be positive if, so dA dt is positive if h is bigger than b, right? And it's negative if b is bigger than h. So let's see. That's not right. That's not right. A is decreasing only when b is less. No, that's not right. A is decreasing when, yes, that's what we said there. So that's right. So a little related rates there. How do you know it's a related rates problem? Because they're talking about rates. Things are changing at so many inches per minute there, so that should tip you off. Let f be a function that's differentiable on the open interval from 1 to 10. If f of 2 is negative 5, and f of 5 is 5, and f of 9 is negative 5, then which of the following must be true? If something is differentiable, it must also be continuous. Differentiability is a stronger condition. You can't be differentiable and not be continuous. So that means it is continuous. So let's see. Let's plot these points and see what we've got here. We've got 2, negative 5. That's down here. We've got 5, 5, and we've got 9, negative 5. So, and we know it's continuous, so it's got to cross this twice. So f has at least 2 zeros. That's true, because it's got to get from here to here and then back again. And it can't have a sharp point, right, because it's differentiable. The graph of f has at least one horizontal tangent. Well, that's true, because if it's going from negative 5 back to negative 5 again, that means the average slope is 0. And if it's differentiable, the mean value theorem says it's got to have a place where the actual slope, it might be at this point, it doesn't have to be. I mean, who knows what else happens, but it's got to have one because the average slope is 0. That's true. For some c between 2 and 5, f of c is equal to 3. Does it have to cross the line c equals 3? It does, right? Because 3 is here. So it does have to cross that. So I think all three of these are true. 1, 2, and 3. This is the mean value theorem, and this is the intermediate value theorem. It just says it's got to actually cross that line, right? If it's differentiable, it means it's also continuous, and the intermediate value theorem says it's got to cross every horizontal line if it's not jumping, skipping, or vertical asymptoting across it. Number 92. Is this the last one? Hey, this is our last multiple choice. Great. So if k is some number between 0 and pi over 2, and the area under the curve y equals cosine x from k to pi over 2 is 0.1, then k is equal to, all right, well, let's set up the integral for this. So the area under the cosine function from k to pi over 2 is equal to 0.1. We're trying to solve that equation. Well, working with this side here, the antiderivative of cosine is sine from k to pi over 2, and we want that to be equal to 0.1. So that means that the sine of pi over 2 minus the sine of k is equal to 0.1, and the sine of pi over 2 is 1. So I've got the equation now 1 minus sine k is equal to 0.1, and just rewriting that, moving things around, move that over to there, subtract that. So we're talking about sine of k is equal to 0.9, so we're looking for k is equal to the sine inverse of 0.9. And since we're looking for between 0 and pi over 2, this is going to give us the right value, right? The sine inverse will always give us an answer between negative pi over 2 and pi over 2. And that is, in fact, where we're looking. So that just makes sure that I haven't been doing physics mode. I'm in radian mode, so we're good. So what's the sine inverse of 0.9? 1.11, I guess 1.120, which is D.